Hello and welcome to Chapter 2. We're going to talk about transformations of quadratic functions, and the objectives for today, we're going to describe transformations of quadratic functions. We'll talk about translations, reflections, stretches and shrinks, and then we're going to write transformations of quadratic functions. All right, so let's talk about translations. I gave you in the last chapter, we talked about how to create the transformational form of a quadratic. It's basically in vertex form, so you should be somewhat familiar with this. So I have my translated or transformational form or vertex form of a quadratic. Y is equal to a times x minus h, squared plus k, where h is the horizontal translation and k is the vertical translation. So for example, something like y is equal to 3 times x minus 5 squared plus 2 is going to shift the parent function y is equal to x squared. Remember, we talked about parent functions, 5 units to the right and 2 units up. So you're going to switch this sign to evaluate or to consider the horizontal shift. So we have the horizontal shift here, vertical shift here, sign stays the same up to, and this is to the right 5. All right, so if I take an equation y is equal to 1/2 times x minus 5 squared plus 2, I end up with a graph that looks like this. I can identify the vertex pretty quickly. And then if I substitute 0 in for x, hopefully I got this right, to find the y-intercept, 0 minus 5 squared is 25. Divided by 2 is 12.5, plus 2 is 14.5. So I can label my vertex and my y-intercept very quickly. So vertex form, or transformational form, is going to provide us with a coordinate for the vertex in the equation. That translates the vertex for the parent function of the origin. So I'm going to translate it 5 units over and 2 units up. And so I end up with my vertex here. All right, this is work that we're going to do together, not quite your classwork yet. And hopefully you have the hang of the classwork program. So I'm going to ask you to translate to provide the horizontal and vertical translations, and then for number 2 I'm going to ask you to graph. And of course I want you to follow the criteria that I've laid out for you for graphing. Please make sure you label the vertex and the y-intercepts as well. So take a moment here to figure out the vertical and horizontal translation or shift for each of these 4. I'm going to pause here and then come back. Okay, so for the first one, we have left 3, down 4. For number 2, we have right 4, up 7, so vertex 4, 7. The vertex for number 1 is -3, -4. For number 3, we have left 1, and then if there's nothing stated here, either in or out, then it's going to be 0. So down or up is going to be 0. My vertex is -1, 0. For number 4, it's going to be left or right 0, and then down 8. And then we're going to graph number 2. I have my vertex at 4, 7. All right, and then I can identify the y-intercept, which we'll talk about a little bit more in detail. I have 4 squared, 16, divided by 2 is 8, plus 7 is 15. And so I end up with 0, 15 as my y-intercept. So just briefly to go through this again, and we'll talk about this shortly. So I'm going to substitute in 0 for x, because all these values here, right, have 0 as an x value. So I want to figure out where the graph crosses the y-axis. I'm going to set x equal to 0. And then I end up with 0.5 times 16 plus 7, which is 8 plus 7, which is 8 plus 7, which is equal to 15. Okay, so this brings us to our first classwork problem, 2.1.1. Same set of problems. I'm going to give to you similar set, I should say, but similar request or same request. You're going to find basically the vertex or the horizontal and vertical translations, and then for number 2, you're also going to graph that. So please pause the video here so you can take care of that. And then we're going to move on. All right, so we're going to move on and we're going to talk about reflections or for a quadratic. All right, so reflections, we're going to have reflections across the x-axis here or across the y-axis here. So this is in relation to our parent function. Again, y is equal to x squared. And we can tell pretty quickly if the graph is reflected across the x or y axis if the function moves from y is equal to x squared to y is equal to negative x squared. Then we're reflecting across the x-axis. Or if it's moving from y is equal to negative x squared to y is equal to x squared as a parent function, we're going to reflect it across the x-axis. So if a has a negative sign, then that function is reflected over the x-axis. And then for reflections across the y-axis, if x has a negative sign, then the graph is reflected about the y-axis. So in a reflection, each point is reflected in such a way that it's the same distance from the point on the original graph to the line of reflection. That distance is the same from the line of reflection to the reflected point here. All right, so at a high level, reflection across the x-axis, reflection across the y-axis, those two different formats. All right, so now we want to determine if the graph is reflected over the x or y-axis and or y-axis. So that's what you're going to state here for each of these four. And then you're going to graph number 1. We're going to do this together. And please identify the vertex and the y-intercepts as well. All right, so let's have you take a moment to see if you can determine. So you're going to pause here. This is not classwork yet. This is work we're doing together. So I'm going to show you the answers and give you your classwork. Okay, so going through the answers, I have yes, I'm reflecting over the x. Yes, I'm reflecting over the y from the parent function. No reflection over the x-axis. No reflection over the y. Yes, reflection over the x-axis. No reflection over the y. No reflection over the x-axis. Yes, reflection over the y. All right, so let's go ahead and take a look at what the first graph looks like. So I'm going to reflect it over the x-axis. I'm going to shift it. Excuse me. I'm going to shift it to the right 3. Whoops. And so it's the value. It's a little bit complicated, and we can discuss this more in class. But I'm taking the value of x that's going to make this value equal to 0. So I'm shifting now to the right 3, and then down 4. My y-intercept is 0, negative 31. Okay, so this brings us to our classwork, your second set of classwork. So a similar program. I'm going to give you a list of quadratic equations in vertex form. You're going to tell me whether or not the parent function is reflected across the x and or y axes, and then you're going to graph number 2. So you can pause here. I'm going to give you a moment to write these down, and then I am going to move on to our next topic. So please write these down. All right. Now we're going to talk about stretches and shrinks. All right, so I'm going to introduce a new form to you, so I'm going to expand this out a little bit, and we're going to talk about the value for b, and this is going to help us with identifying a little bit more clearly stretches and shrinks. So just keep this in mind. So we want direction factor of stretch, and then the shrink and stretch itself. So those three items we want to consider. Okay, so let's talk about direction of the shrink. So I have two values, the absolute value of A and the absolute value of B. A is going to determine the vertical stretch and shrink, and B is going to determine the horizontal stretch and shrink. So when there is a coefficient that's outside the parentheses, that determines a vertical stretch or shrink, and when there's some coefficient inside of the parentheses, that value determines the horizontal stretch and shrink. When the absolute value of A or B is greater than 1, the graph moves towards the y-axis. When A or B is less than 1, the graph moves away from the y-axis, or it gets wider. So these parentheses are important in the evaluation, so I want to make sure that you keep them. I will tell you that I'm giving you a little bit more than your book does, just because it's required for you fully to understand how the stretches and shrinks work. So let's give you an example. I have y is equal to, and this is why the parentheses matter. I have my, let's say the function that I'm going to stretch or shrink, y is equal to x minus 2 squared, and that's going to be here in blue. And if I use that value for b in parentheses, then I am, with the parentheses, right, we said these parentheses are important, then I'm stretching, let's say shrinking this graph away from the y-axis. If I don't include those parentheses, then this is an entirely different function altogether. I'm shifting it. I am making it wider, yes, but when I don't use the parentheses to identify that b value, it does change the entire function itself. So you have to be careful about this b value, making sure it's outside of these inside parentheses when you're multiplying that half value in order to relate it to the original function of y is equal to x minus 2. And this is something we're going to have to go through a little bit more in class because it is fairly complicated and will take you a couple of tries to figure out what's going on. All right, so let's talk about reflections as well. So again, I'm going to differentiate between values outside and inside the parentheses, and y we specified a negative x value as a reflection over the y-axis. So I said here this b value as part of the stretch and shrink evaluation needed to be outside of these parentheses. However, when we talk about reflections, so we're not talking about stretches and shrinks, we're talking about reflections. When we talk about reflections over the y-axis, that negative value needs to be assigned to the x and not to the b value. If you assign it to the b value, then it doesn't do anything. So this value, or this equation, is the same as this one graphically. In order to reflect it, we need to change that negative or plus sign to this x value. Okay, so just keep in mind that when you're applying a negative sign in order to reflect it over the y-axis, that negative sign needs to be applied to the x. All right, so let's talk about whether or not there's what the direction of the shrink or stretch is and whether or not it's horizontal or vertical. And you guys can pause here, and then I'm going to come back and we'll go through the answers together as classwork. So direction of the shrink or stretch and whether it's horizontal or vertical. And remember, you can go back to this key here while you're doing this. All right, so please pause and let's come back in a moment. All right, so in this case I have a horizontal stretch. It's towards the y-axis. Remember, it's greater than 1. In this case I have a vertical stretch because it's outside the parentheses. It's going to be away from the y-axis because it's less than 1. I have a horizontal stretch or shrink, it's going to be away from the axis, it's less than 1. And I have a vertical shrink, it's going to be away from the y-axis, it's less than 1. All right, we're going to pause here. We're going to come back and continue our conversations about horizontal stretches and shrinks in the next segment.